Today we will record this session on vote contract or DAO application, which is a decentralized autonomous organization DApp developed on aelf blockchain. So this is the most complex contract in this particular guide which we are following. Now it will cover voting mechanism, and it is simply like how a particular user can join the decentralized autonomous organization, then how they can create proposals, and then how they can vote on those proposals. So there are 4 steps in this process. We will first set up the development environment, then we will develop the smart contract, then we will deploy the smart contract, and in the last step we will interact with the deployed smart contract with the front end application that is developed in React.js. In the first step, we will set up the development environment in the local system, where we should have basic knowledge of terminal commands, and then we should have an IDE. You can install an IDE of your choice. I will be using VS Code. I have already installed VS Code in my system. If you want to install VS Code in your system, you can simply go to this link and download for your system. Then in the next step, we will install .NET 6.0 SDK simply. So there are installer packages in Linux, Mac OS, Windows, and other scripts as well. You can install according to what system you are working on. After that, we will install the aelf contract templates. So we will copy this command. So first I will check whether the .NET is installed on my system or not. So I will check .NET version. If it is installed, then it will show me the current version of the .NET. Here I can see that the .NET is already installed on my system, so I will not install it again. Now in the next step, using .NET, I will install the aelf contract templates. I will copy this command and then I will paste the command in the terminal. And once I paste this command in the terminal, it will install aelf contract templates. It says that it is already installed. If you will install it first time, it will install the aelf contract templates on your local system. In the next step, we will install the aelf deploy tool using the .NET tool. So we will simply copy this command and then we will go to our terminal again and we'll paste this command, and it will install aelf deploy globally into our local system. It will take some time to install. We will see the process, and then we can invoke the tool using aelf-deploy, and now we can see it was successfully installed. In the next step, what we will do, we should have the Node.js installed in our system, and then we should have Yarn installed in our system. If you haven't installed Node.js on your system, you can follow this link and download Node.js. I will check whether I have installed it. So I will check the Node version. You can check the Node version after you install whether it was installed successfully or not. Here it says that I have already installed Node.js with version 20. Then in the next step, I will check whether I have installed Yarn on my system or not. If it is already installed, then I will simply skip the step of the installation. If it is not installed on your system, you can simply click on this link and download Yarn using npm command. As you will be installing it globally, you can use sudo along with this command. In the next step, we will install the aelf command using npm package. Now we will copy this command and then we will again go to the terminal and we will paste this into the terminal to install the aelf command using npm package. As it is using -g flag, it will be installing globally. So it might throw an permission issue. If it throws permission issue as it says that required permission are not given when you get e-access, you should use sudo with that command. So we will use sudo with that command, and then we need to provide the password of our system. And once we do that, then it will install aelf command on our local system. In the next step, what we will do is we will install Git. If you can check whether it is already installed on our system or not. If not, then you can follow this link and install based on your operating system. I will check whether it has been already installed or not. So I will check the Git version, and if it is successfully installed on the system, you can also check the version using command git version. And if it shows a version, it means that it is successfully installed. At this point, we have completed the first step of our DAO contract, or you can say DAO application or vote contract on aelf blockchain. Now we will start the next step, that is developing the smart contract. In this step, we will develop the smart contract for our DAO application or vote contract. Now here we will create a new directory called capstone aelf, and then we will change to that directory. So first we will copy the mkdir command. I am copying so that I don't make a mistake. So I will copy this command and I will create a new directory, and then I will change to this directory. After that, I will create the capstone project using the .NET new elf command. The project name is builders DAO. So I will just copy this command and paste here, and it will create a new project for me. How to check whether the project was successfully created or not? You can do ls. If source and test folders are present, it means the project has been created successfully. In the next step, we will open the project in the IDE. We will open VS Code and open this new project in the VS Code. We will open this folder. It is part of the ELF tutorials folder, and the folder name is Capstone ELF. I will open this project inside my IDE, that is VS Code. In the source folder, you will see certain files and a folder called protobuf. So inside folder protobuf, there is a directory called contract, and there is a file called hello world contract.proto. So here, as you can see in the instruction, that we need to rename this file hello world contract.proto to builders.proto. So I'll copy the name and I will again go to the project and I will rename the file as builders.proto. Now, once it is done, I will open this file. Here you can see there is some code already written in this file. So proto files are the files where we define all the functions of our smart contract. Now we will define all the function and messages functions, or you can say methods as well. And messages are similar to events. So we will define the methods and the messages inside our proto file. Now, in the next step, here you can see the builders out of proto. And here you can see there are certain functions as defined as RPC. The function names are initialize, join DAO, create proposal, vote on proposal, and get all proposal, get proposal, and get member count, and get member exists. So these are the functions, or you can say these are the definitions of all the functions which are part of our builders DAO smart contract. Below you can see there are certain messages or certain events. First message name is member, second message name is proposal, third message name is create proposal input, and there are other messages like vote input, member list, and proposal list. I will explain the definition, or you can say I will explain the working of all these functions later on. So first we will copy all the definitions of the functions. We will go to builders.proto file. We will select all the code and we will paste the new code here, which we just copied, and we will save this file. So now we have defined all the functions which are part of our smart contract in the proto file. Proto file contains all the methods and messages, or you can say the definition of all the methods and messages in the proto file. In the next step, we will implement these functions. Now, let's understand what we have done in the proto file. We have defined the proto version and we have some certain RPC methods. So those methods are initialize, join DAO, create proposal, vote on proposal, and then there are getter functions as well, like get all proposals, get proposal, get member count, and get member exist. Then there are certain message definitions, which is member, proposal, create proposal input, vote in member list, and proposal list. So these are all the messages or events of our smart contract. Now we will first define the smart contract state so that we can use those state in certain situations. Now those states are named as initialized, members, proposals, and member count, and next proposal ID. The members and proposal state are mapped state type, initialized is bool state type, and member count and next proposal ID are int32 type. So what they mean is they define which state the smart contract is. So we will copy this code and we will again go back to our VS Code or IDE. There we will see a state file that is named as builders.state.cs. That is a C# file to define the state of the smart contract. We will select all the code and we will paste the newly copied code here and we will save this file. Once we save this file, we have saved the state of our smart contract. In the next step, we will understand what the state file does. So here are certain state variables as I explained: members, proposals, member count ID, and next proposal ID, in which two are mapped state type and two are int type. Now, mapping each member to a boolean indicates that whether they have joined the DAO or not. Proposal means mapping each proposal to an ID for identification and retrieval for a particular proposal. Member count ID and next proposal ID track total number of members and proposals. In the next step, we will implement the logic of our voting smart contract. Now here, as we have defined the builders.cs file inside the source folder, we can see there is a file called builders.cs already. Now we will implement all the functions. Here you can see this particular code contains all the definition of all the functions, but again, it doesn't contain the implementation. We will do the implementation in the next step. First, we will simply copy all the definitions, and in the next steps, we will implement the function. So in this case, we will copy the code, we will select all the code, and then we will paste the newly copied code here. We will save this file. In the next step, we will implement these functions. First, we will implement the proposal logic function, or you can say implement the initialize function. So we will copy the code of the initialize function, and then we will go to initialize function inside the VS code, and then we will select the definition and we will paste in place of that. And here, this particular function actually defines a new proposal, which is a dummy proposal, that is a proposal number 1 with ID 0 with some description, and the status is in progress and vote threshold of 1. And there are certain other state which are defined in this. So this is a hard coded proposal which we have created in the initialize function. Initialize function actually initialize our smart contract state, and it tells whether a particular smart contract has been initialized or not. In the next step, we will implement other functions. First, we will implement the join DAO function. The join DAO function actually allows users to join the decentralized autonomous organization. So we will copy this code. As you can see, the implementation is still incomplete, but we will copy this code and we will paste it and we will implement it in the next steps. So we will select the join DAO function definition and we will paste the incomplete code of join DAO here. Then we will save this file. In the next step, we will implement the next functions. The next function is create proposal function. Here you can see the implementation of the create proposal function. When a new user has joined the organization or joined the DAO, in the next step, they can create the proposals. They can create proposals on certain topics. This function actually allows new users to create the proposal with ID, title, description, status, and vote threshold. And then it defines two other state variables, which are yes votes and no votes, which keep steps of the votes done on the certain proposal. So now we will copy this code and we will paste it in place of the create proposal definition. We will paste it here. This function, as I explained, allows users to create the proposal on a particular DAO. In the next step, we will implement the next functions. The next function is vote on a particular proposal. So this particular function allows users or allows the DAO members to vote on a created proposal. We'll copy this code and we will go back to our VS Code file, and then we will paste in place of the definition of the vote on proposal function, and then we will move to next step. In the next step, we will implement the next function, that is get whole proposal. This is the first getter function we will implement. So here you can see again the implementation is still incomplete, but we will copy this code and we will paste it in place of the definition of the function that is called get all proposal. In the next steps, we will implement the next functions, which are other getter functions. We will again copy the code of other getter functions, which are get proposal, get member count, and get member exist. To explain, get all proposals get the list of all the proposals which are already created. Get proposal gives the detail of a particular proposal. Get member count defines how many members have joined the DAO, and get member exist function tells you whether a particular member or a particular address is part of the DAO or not. So we will copy the code of all other getter functions and then we will paste it in place of the definition of all three functions. So please make sure you select the definition of all the functions properly and then you paste the code properly here. Once you paste the code, it means that we have implemented all the functions, that is get proposal, get member count, and get member exists. Do remember that we have still two incomplete functions. So now we will complete those implementation. First, we will complete the implementation of join DAO function. Join DAO allows the users to join the DAO, or you can say join the decentralized autonomous organization. So we will select the definition and the incomplete implementation and we will paste it properly, and we will make sure that we do not duplicate the name of the functions in the smart contract. Then The next function which is incomplete is the get all proposal function. So we will copy again the code of that function and then we will paste in place of the incomplete implementation of this function. So here we can see the get all proposals function is there. We will select the code and we will make sure that we do not duplicate the name of get all proposal functions in the function in the smart contract. We will again save this file. At this point, we have completed the implementation of our smart contract. This is the completion of our second step. Now in the next step, we will move to the deployment of the smart contract. In this step, we will deploy our smart contract. Deploying means we need to put the code which we have implemented for the DAO DApp to the blockchain or on the aelf blockchain. Now, to deploy a smart contract, we should have an account or we should have an wallet on a particular blockchain. Now we are dealing with aelf blockchain, so we will create an account on aelf blockchain using aelf command. We will first copy the command, we will go to our VS Code and we will open the terminal, and in the terminal we will paste this command aelf command create. This will create a new account for our users. If you see a similar issue of unsupported developer envelope routines, then you can check the node version and then you can update the node version to 20 or latest node version. You can use the command nvm use version 20. So I have already installed version 20. I just need to switch to version 20 so I can use nvm. You can, if you haven't installed nvm, so you can directly install the node 20 version. If you have node 20 version, you will not face this issue. Again, I'll try creating a account using aelf command create, and in this step you can see that there are four things which has been created for me. One is mnemonic, one is private key, one is public key, and the other one is the address. I need to save this information to a file, so I need to select Y and then I'll press enter. And it will ask me to save this information in a file which is password protected, so I need to provide the password of that file. I will provide a password to this file and confirm my password. If we both are same, then it will save the information to a file. So these four information are really important. Let me explain what they are. Address is the unique identity of a particular user to interact, or you can say to do functions invocation on the blockchain. Then public key is the cryptographic identification, or you can say cryptographic public key, which is available to the user and is also visible to the other users. Then private key is private to users, which is used to sign the transactions. And mnemonic is, you can say, mnemonic is simply a representation of the private key, and address is a representation of the public key in a simple format. So mnemonic is a combination of words which is presentation of the private key. As we have saved this information, we will use this information in our next steps. So now again, in the next step, we will first set an environment variable that is wallet password. So we will copy this command and then again we will go to the terminal. We need to set this password. So my password is the password which I used to save the file, which was Mohit at 123. You need to use the password which you used to save the file. So I will export this environment variable, and then in the next step, I will export another environment variable that is exporting the wallet address. So now again, I will copy this command and I will paste this command here. Your wallet address is the address which you created with aelf command create. So this address is the address you need to paste here. So I will copy this address, I will paste it here to set the environment variable of wallet address. So I will set this. Now in the next step, I will first get some tokens to deploy the smart contract. So whenever you need to interact with the blockchain and you need to change the state of the blockchain, you need some tokens or you need some transaction fees to do a transaction. Every smart contract deployment or every smart contract function invocation where the value or you can say the state of a blockchain changes, you need to pay the transaction fees. So we will get some test tokens from the aelf faucet using the next command. So we will use the next command. We will copy this command and then we will paste it in the terminal to get some tokens in our account. So we have provided certain information. Here you can see we have provided our wallet address to provide some tokens to our wallet address. Here we can see if success is true, it means the balance has been created of some tokens to my account. Now to check the balance, I can check the balance using the next command, that is elf command call. And there is a address of a multi-token contract, which is a contract to define all the token states in elf blockchain. So I will paste this command. Here other parameters are wallet address and wallet password, which will provide the information of my address and my password to get the balance on the test network. This is the URL of the test network of elf blockchain. I will call the get balance function. Then I will press enter. Here I need to tell the symbol of which token I want to check the balance. So I will type ELF, that is the ELF token on testnet. Then I will have to provide the owner information. Owner is the address which we created using elf command create. So we will paste that address here. And once we do that, here we can see there is some balance for elf for this owner. Now you can see the balance is 10 into 10 to power 8. So 10 to power 8 are the decimals of this token. So it means this user has 10 ELF tokens, which can be divided into 10 to power minus 8 smallest units. So the smallest unit is 1 into 10 to power minus 8. Now we will deploy the smart contract as we have already gotten some tokens. So for that, first we need to build the smart contract. So first we will go to our source folder. So we will change the directory to source folder. Inside this source folder, we will run the command .NET build. Here we will press enter. It will build the smart contract which we have written. Once the build process is completed, inside the source folder, there is a new folder which will create, that is a bin folder. So we will wait for this process to get over. So first building means we are simply compiling the smart contract here. As build process takes some time, so here we can see that the build process is complete and build is succeeded here with a warning. We can ignore the warning. And now in the next step, we will deploy the smart contract. So to deploy the smart contract, there is another environment variable we need to set, that is a contract path. So as I said, in the build process, there is a new folder that is created, that is bin. Inside bin, we can check there is a new file called .dll.paste. We need to copy the path of this file and set this path as a contract path. So we will export this. So first we will copy the export path, export contract path equals to, so we are setting a new environment variable here, and then again we will copy the path of .dll.paste file. We'll paste it here, and then we'll check again that we need to set the contract path, and then we will set this environment variable. And once we do that, in the next step, what we need to do, we need to deploy our smart contract using the next command. Elf deploy is the tool which we installed in the installation process in the first step, where we set the local environment. Here we need wallet address, wallet password, and contract path to be set as environment variables. Two we have already set in our terminal, and the third, which we just set, of the builders.dll.paste file. And then this is the testnet URL. Now we will enter this command, and if it is saying that elf deploy is not found, then you can install elf deploy again. So we will again go back to our first step, that is a local dev setup, and then we will see the command used to install the elf deploy tool. We'll copy that and then we will paste it in the terminal. If it shows it is already installed, you can uninstall it first, which we have already seen in the hello world contract also, and you can install it again using the same command. Now as you can see, it is successfully installed, but before moving to the next step, first we need to export the path. So we'll copy this path command, and then we will set this path environment variable, and then we will try deploying the smart contract again. So we will again call the elf deploy command, and then we will press enter. It will start deploying. So it will take some time to deploy. As we can see, the deployment process has already been started. So deployment means we are putting the smart contract code on the blockchain. So in this process, what exactly happens is we put all the smart contract code, you can say the byte code, on the blockchain at a particular storage which we can invoke. And that particular storage has some identity that is defined as an address. So now the output of this deployment process is the address, or you can say deployed smart contract address, which will be returned when this smart contract is successfully deployed. So now we are waiting for the deployment process to complete, which will return a smart contract address. Till this process completes, we will see what we have done till now. We have set up our local environment on our system, then we have developed our smart contract, and in this step, we have deployed the smart contract on our aelf blockchain after completing the implementation. Once this deployment process finishes, then we will see the address of the smart contract. And now we need to set this contract address as an environment variable. So we can copy the next command and see whether the deployment process is complete or not. Here we can see the deployment process has been completed and there is an address you can see, that is a deployed smart contract address. So we will set that as an environment variable. We will export the contract address equals to the address returned by the deployment process. So you need to copy the address which you get after the deployment, which you do on your local system, and then we will set this contract address as an environment variable. So this was the third step where we have deployed our smart contract on the aelf blockchain. In the next step, that is the last step, we will interact with our deployed smart contract with a front-end application. In this step, we will interact with our deployed smart contract. So first we will set up the project. So we will clone the front-end code. So here we will go to our project directories. You need to clone the code inside the source folder so you can change the directory. So you can go back to the parent folder, not inside Capstone Elf. You can clone this separately. So we will clone this front-end code from GitHub. So the command is written, the link is given. Now we have cloned this code and then we will change the directory to front end. Here we will go, we can check whether it is installed or not. So it is cloned properly. Now we will change the directory to vote contract front end. Now here we are inside vote contract front end. You can open this separately or maybe in the same folder. So we will open it separately to understand it better. Then in the VS Code. So here the front end repo is here. Now we might need to change some of the things to make it work. So first we will install the necessary libraries. So we'll use the command npm install. So once we have opened this inside our IDE, we will open the terminal, and here in the parent folder we will run npm install. You can check where the package.json file is there. You need to run npm install there itself. So we will run npm install here. It will install the required packages. Now we will go to the next step. We will configure portkey provider and write the connect wallet function. So portkey is a wallet which is used, like you can say, as a account, or you can say which stores the information of an account. Wallets are somewhere where private key and public keys are stored, and they are used to sign the transactions and interact with the blockchain smart contracts. So we will write this in an algorithmic way. First, we will go to source use DAO smart contract.ts file. So this application is written in TypeScript. We will go to source and then we have a file named use DAO smart contract.ts. Use DAO contract.ts. Here is the implementation. Now we will set up the portkey integration here. Now what we will do is, here the step A is written and then we need to copy the code of this use effect, which will actually check the provider for the blockchain ID TD VW, and then if it is not there, it will say that no chain, or you can say no portkey is installed, and then there is a smart contract address which we will replace later, and then that is the address of our DAO smart contract which we will use for our own smart contract, and then we will get the state of our DAO contract in this. So we will copy this code and we will see where the step A is written. Here you can see we need to change this use effect and we select this properly. Make sure that we don't duplicate this, and then we will paste this here, and our step A is finished. Here we can see our step A is finished, where we have implemented the portkey integration. Now in the next step, we will go to source home.dao.tsx. So this is our step B, where we will connect our portkey wallet. So now we will again copy this code and it is inside home.dao.ts. So we will open home DAO.tsx. This is the file. So here we will check where the step B is written. So the step B is here inside the connect function. So make sure you have copied properly. If you are copying the complete function, then you need to select the connect function here and then you paste the new code here. Here it actually connects your portkey wallet when you try connecting with the front end application. So we will save this file. Now in the next step, we will initialize the smart contract. So this is the step C. So we will write the initialize smart contract and join DAO logic inside our front end application. So now we will replace the initialize and join DAO function with the following code snippet. Again, this is the step C, and again we will go to home.dao.ts. We will copy this code and then we will go to home.dao.ts in the third step. Select the initialize and join DAO function and then paste the code which we copied, which is the implementation of initialize and join DAO. Then save the code. In the next step, you can see the explanation that what the function does. So it fetches your wallet account using the portkey wallet provider, and then it initializes the DAO smart contract which we have installed. And if it hasn't been done already, so if it is not initialized, then it will initialize, and then it will update this state, and then will show a success alert. And then it calls the join DAO method for your wallet address, and then update the state and shows a success alert. Now we will wrap this initialize and join DAO function inside the button as well to trigger when we want to initialize and join the DAO. So we'll have to see that we have already done it or not. We'll go below and we can search whether we have done it or not. Here you can see there is a join DAO button, which on click we are calling the initialize and join DAO function, which we just implemented in step C. So this is the function. Now in the next step, we will write the create proposal function inside the source create proposal.tsx file. This is step D. We will configure the proposal form, and now we will copy this. So we will configure the form and then we will see like where the step D is. So we will check this is the step D and then we will configure the form here. We'll paste the code here. Please make sure you don't duplicate and then we will paste it. Go to next step. After this, we need to note that current wallet address has the default value because the wallet address is passed from the home.dao.tsx file. So when the user clicks create proposal on the landing page, it calls from the home.dao.tsx. Default value is the current address value, as you can see here. Now this function, what it does is it initializes a new form variable with default values needed to create a proposal, and it includes the fields called addresses, title, description, and the vote threshold. And the form is ready. Now let's write the create proposal function for the form submission. So this will write the logic of the create proposal. So on submit function we need to change. So this is step E. We need to copy the code for the on submit implementation, and then we will select this code and we will paste it here properly, and then we will simply see we have saved this file or not. So we will save this file for the on submit function. So this function actually creates a new proposal input variable with form fields, title, description, and vote threshold, and it invokes the create proposal function of the deployed smart contract using the current wallet address and proposal input. And if it is successful, then it navigates the user to the landing page and shows an alert that the proposal was created or not. Then we will write the vote and fetch proposal functions. So now we will go to source home.dao.txt again and scroll to the step F, and we will replace the vote yes function. So if someone does the vote yes, step F, so we'll go to home.dao.txt and this is the vote yes function. We'll select this and we will paste this. Now we have implemented the vote yes function in this file. So we'll save this file again. In the next steps, we will understand what this function does. So it takes index as a parameter, and then it fetches the wallet address with the portkey provider. Portkey is the wallet, as I explained earlier. And then it creates a vote input parameter, and with the wallet address, proposal ID, and a true value for the yes vote, and calls the vote on proposal function for the smart contract, and then updates the state. Then we will go to the next step, that is step G. We will update the use effect of fetch proposals and replace the use effect hook for this code snippet with this code snippet. Then again, we will go to homedao.tsx and we will check the step G. Now let's go to homedao.tsx and here we can see the step G is here. So we'll update this use effect, paste it here. Now we will save this file. So this is the step G use effect. So we'll save this file. In the next step, this function actually fetches the proposal function. It defines the fetch proposal functions that fetches the wallet address, and then it calls the get all proposal function from the smart contract, returning a list of proposals. And it also updates the state and shows an alert once the proposal are fetched. Now we have saved all the files. We will check whether we have saved all the files properly or not. Then we will try running this application using npm run dev. Now we will go again to the parent or vote contract frontend and we will run npm run dev, and we can see the application is running successfully on this local host link. So we'll copy this link and we can check. So here it is successfully running. Now we will again go to the next step. There is a tip listed for you. Now this is the application which we have already been directed on 5173. So you can read the tip. If you are testing GitHub code space, that is a different step which you might have taken instead of your local development. You can read the tip accordingly. Now after that, in the next step, we will create a portkey wallet. So portkey wallet you need to install simply from the Chrome Web Store. So click this link and install. Here you will get an install button. As I have already installed this, I need not install it again. It is already there in my system. You need to install it, and once you download the extension, you can click on get started, and then you can sign up using your Google account, your Apple account, or your phone and email. Then make sure that you select the ELF testnet, because you need to create an account on ELF testnet as we are dealing with ELF testnet first. So now we will see that we have done this integration. So once you set up the portkey wallet successfully, you can open the portkey and then you can see all these details, as I can also show you all the details of my portkey wallet. So you will see the balance as 0. Now I will check the network, which network I'm using. I am on mainnet right now. So I'll switch to testnet because I need to use testnet. It will show me the dev mode, and I have certain balance of ELF tokens here. So you need to get that using the faucet. So that there is a faucet link given above. You can use that to get certain tokens. First, we need to create on connect wallet to connect the portkey wallet, and the button will change to connected. So we will go to our local host, then click on connect wallet. It will open our portkey and then we will approve. So once we approve, it will show an alert that it is successfully connected and the button will change to connected. Now in the next step, we will click the join DAO. So it will be prompted to sign the initialize function and then join DAO methods as shown below. So now click on join DAO. So we'll again go to our local host, click on join DAO, and DAO contract successfully initialized is showing, and then successfully joined DAO, and it has fetched proposal. So we click OK, and once we do that, then it will show certain proposals. You can refresh this page. So now it has fetched all the proposals. So these are 2 proposals which has already been created. Now, after that, proposal 1 was defined and proposal 2 was initialized on my address. So now we will test our vote functionality next. So we can proceed to click on vote yes. So again, we will go to local host. We will create on first proposal. You can vote yes. So it will open portkey and it will ask me to sign the transaction using the portkey wallet. So once I click on sign, it will sign the transaction. So here it will show that voted on proposal successfully. So Now it has fetched the proposal again successfully, and here we can see the yes votes has changed from 1 to 2. Now in the next step we have already signed, so proposal status has changed as the yes vote has changed. So status will also change to passed. Here you can see the status has also changed to passed. So now you can click on create proposal to create a new proposal. Again, go back to your localhost, click on create proposal. The title is, let's say, what tutorial proposal, we will name it. And then it's the description is tutorial for the DAO contract. And vote threshold, let's say, is 10. We will submit it. As we are changing the state, it will create a proposal for us. So we will wait for the proposal to be created. So once we click on the submit button, it will open a notification. We'll check the activities. So we can submit again. Then it will open a port key alert box. So we need to sign to create the proposal. And once we sign, it will take some time to create the proposal, and this proposal is successfully created. I can check the list that we just created a new proposal, that is vote tutorial proposal, and it is in progress. Now we can again connect the wallet if it is not connected, and then in the next step, so you can give the titles and description and vote threshold according to need, and then we followed this process, and then successfully we have created the proposal. So now we have completed the fourth step, that is interacting with our deployed smart contract. So what we did is we simply called certain functions, that is join DAO, which initializes the smart contract and calls the join DAO function for a particular port key account. Then we created the proposals using our account. Then we voted on some proposals, and then we saw if the threshold is reached, then it shows the state as passed. So in this tutorial, what we have learned is we followed 4 steps. First is setting up the development environment. Then in the next step, we developed the smart contract, where we implemented certain smart contract functions and messages. Those are events which are used for a web application to check whether a particular state has changed or not. Then after that, we deployed our smart contract on the aelf blockchain by creating an account on the aelf blockchain and by getting some tokens to deploy the smart contract. In the next step, we interacted with our front end code. So where we set up our project, and then we configured our port key provider. So we installed our port key wallet. Port key wallet is used for aelf blockchain to interact with the smart contracts. And then we invoked certain function on the smart contract, and then finally we concluded by running the application successfully. So this was about vote contract tutorial. If you have any questions, you can reach out to us. Thank you. Stay tuned.